In this video, we will discuss solving quadratic equations by factoring. So we'll focus on how to solve a quadratic equation using the factoring techniques. We have talked about various techniques for factoring. We have talked about how to factor difference of squares, how to factor difference of cubes, sum of cubes, how to factor using the x method when the leading coefficient is 1 for quadratic trinomial, and also how to factor when a is not equal to 1, the leading coefficient is not equal to 1. And the very first thing when you are going to factor an equation or you're going to factor an expression is to pull out the GCF. We also learned how to factor by grouping when you have 4 terms, right? So in this video, we'll focus on all those methods. Let's first talk about first step would be to write the quadratic equation in standard form by writing as ax squared plus bx plus c equal to 0. That means the term with the x squared first, then the term with the x, and then term without x, and 0 on the other side. Okay, you may have the b as 0, a will not be 0 because then it wouldn't be a quadratic equation anymore, but b or c can be 0. It would still be a quadratic equation. The next step is to take the GCF out if there is any, and then divide both sides with the GCF. If the GCF is a variable, then do not divide with that GCF, okay? If quadratic has 2 terms, then we want to use the difference of squares or sum or difference of cubes. If quadratic has 3 terms, then factoring using x method or AC method. If quadratic has 4 terms, then we would go with grouping method. After factoring using zero product property, we will be using zero product property, which says if product of 2 terms is 0, then one of them must be 0. Product of 2 factors is 0, one of them must be 0. And lastly, we will be solving by plugging each factor equal to 0 and solving for the variable. The answers you get for the variable are also called solutions, roots, zeros, or the x-intercepts. We'll talk about some of this terminology later in the course. For now, we can say those are solutions to our equation. That means if x becomes those numbers, then the left-hand side of equation turns into 0, which is equal to right-hand side of equation. Let's look at some examples. Earlier, we talked about the bottoms-up method. I will be using the bottoms-up method for each of these. For the first problem, example number 1, let's look for a GCF. Is there a GCF in here? It doesn't look like there is no GCF. So if there's no GCF, that means I'm going to write a times c on the top, b on the bottom. A times c is 6 times 3, which is 18, and b is 11. Two special numbers, which will multiply to give me 18, add up to give me 11, are 9 and 2. And because my a is 3, I'm going to be dividing both sides with a 3x and a 3x. Now let's see if I can simplify any of these fractions. Looks like the first fraction can be simplified and second cannot be. Once your fractions are simplified, use the bottoms up and you have your factors. So x plus 3 is your first equation and 3x plus 2 is your second. X plus 3 is the first factor. Sorry, it's not an equation. 3x plus 2 is the second factor. Now it's time to use zero product property, which says plug each factor equal to 0 and solve for x. So either x is negative 3 or 3x is equal to negative 2 and x equals negative 2/3. Right? Example number 2, we have 9x squared plus 7x equal to 2. The first step would be to bring everything on the left-hand side and write it in the form, standard form. Now it is time to find out the GCF, which looks like there's none. And it's time to think about two numbers that multiply to give me 9 times negative 2 is negative 18. And two numbers that add up to 7. So let's think about two numbers that multiply to give you negative 18. They add up to positive 7. They're 9 and negative 2. And my first number is 9. So I'm going to divide both of them with a 9x and a 9x. Okay, it's time to simplify. The first fraction can be simplified. And I'm left with the factor x plus 1 from the first one. And the second fraction gives me the factor 9x minus 2 equal to 0. At this point, if you want to FOIL x plus 1 and 9x minus 2, you can go ahead and do that to make sure you factored it correctly. Otherwise, if you're confident on your work, then there's no need to do that. Once you have product of two factors is 0, we can use a zero product property that says one of them must be 0. Either x plus 1 is 0 or 9x minus 2 is 0. Leaves me with x equals negative 1 or x equals 2/9 when you solve for x. Okay. So whatever is the degree, that's how many solutions you are expecting. Sometimes solutions can be repeating, so you may not have exactly two distinct solutions. They could be repeating solutions. Next example, number 3. Okay, very good example, easier example. We already have 0 on the right-hand side, and the left side is already factored. That means half of it is done for me. I can start from using the zero product property because our goal is to have a 0 on one side and factor the left-hand side. Those two things are already done over here. So that means I can use the zero product property, which says either y minus 2 is 0 or y plus 3 is 0, which means either y is 2 or y is negative 3. There's my two answers. Example number 4 is slightly different. It looks like it is similar, but it's not because you have the 6 on the right-hand side. Now, you can only plug each factor equal to 0 if you have 0 on one side. If you don't have 0 on one side, then zero product property, then this property doesn't work because product of two factors can be 0 if and only if one of them is 0. But product of two factors can be 6. One of them can be 1, the other one can be 6. The first one can be 6, the other one can be 1. One can be the 2, the other one can be 3. The first one can be 3, the other one can be 2. Or we could be dealing with 1/6 and 1/6 and 36. They would still multiply to give you 6. Or we could be, there are lots of possible options. So lots of possible options that will multiply to give you 6. So that's why we cannot plug each of these factors equal to 6. What we need to do instead is we will have to FOIL the left-hand side and then bring everything to one side to get a 0 on the right-hand side. Let's go ahead and FOIL first, outer, inner, last. First times first, y times y is y squared. Y times plus 3 is plus 3y minus 2y minus 6 equal to 6. Now it is time to bring everything to left-hand side, everything to one side, and combine the like terms. 3y minus 2y is a plus y minus 6 is 0. Y squared plus y minus 12 is 0. Now I have a quadratic trinomial and I'm thinking about two numbers that multiply to give me negative 12. They add up to give me positive 1 are 4 and negative 3. Good thing my leading coefficient is 1 over here. So whenever your leading coefficient is 1, you can go ahead and skip the step of dividing with a y on both sides. You can if you want to, but there's no need. Y plus 4, y minus 3 are my factors. Now it is time to use the zero product property. Either y plus 4 is 0 or y minus 3 is 0. So this gives us y is equal to 3 and 4. Two possible answers, 3, 4, 3 or 4. So this equation is true when y is either 3 or y is 4. Okay. So keep in mind, if you have 0 on the right-hand side, that's okay. You can go ahead and use zero product property. If you don't have 0 on the right-hand side, we cannot use zero product property. Let's look at example number 5. I already have a 0 on the right-hand side. That's a great news. That means I can go ahead and plug each factor equal to 0. Either this factor is 0 or 3x plus 1 is 0. So now I'm going to be solving for x in these equation. X comes out to be 3/2 or 3x is negative 1. X turns out to be negative 1/3. So there's my two answers. Okay, 2x cubed equals 18x. All right, first step is to bring everything to one side. And once I got everything to one side, it is my goal to go ahead and factor out the GCF, which looks like 2x inside 2x is a common factor in both the terms. X squared 9 is what I'm left with. Now, x squared minus 9 is a difference of squares. So a squared minus b squared type when we talked about special products. Now I factored x squared minus 9 to x plus 3 and x minus 3. And we can use the zero product property now because I have a product of a few factors equal to 0. That means one of them must be 0. Either 2x should be 0, or x plus 3 should be 0, or x minus 3 should be 0. So if I divide both sides with 0, 0 divided by 2 is still 0. So that's my one solution. X equals negative 3 is my other solution. X equals positive 3 is my other solution. I'm just isolating x from each of these. Okay, next we are going to look at example number 7. In example number 7, we have 9x squared minus 24x minus 16. So my goal is to first bring everything, all the terms to one side, get a 0 on the right-hand side. Let's go ahead and give that a try. 9x squared minus 24x plus 16 equal to 0. Well, 16 times 9 is, let's see, 16 times 9 is, okay, 144. And we're looking for the numbers to add up to negative 24. So there'll be 12 and negative 12 and negative 12. We can do that. Or you can also use the special products that we've talked about, that this is a perfect square trinomial because your first term is 3x quantity squared, and the last term is 4 squared, and the middle term is 2 times the first term times the last term. That means it is a perfect square trinomial. So when you factor it, it turns out to be you bring the 3x here, you bring the 4 here, and you bring the sign of the middle term and square the whole thing. So here we have 3x minus 4 squared, which is same thing as 3x minus 4 times 3x minus 4 square of something means you have two of those. And now we can use the zero product property, which says 3x minus 4 is 0, or again the 3x minus 4 is 0. So when we try to solve for x, x comes out to be 4/3. In this case, you do have a repeating solution. You are expecting two different solutions, or you're expecting two solutions, but you're getting the same solution twice, okay? It's a repeating solution. You didn't have to use the special product method here. You could use for example, number 7, you could still use the 9 times 16 is 144 and negative 24. You could still use the bottoms up method, and your two special numbers would be negative 12 and negative 12. They multiply to give you 144, add up to give you negative 24. And we would divide both sides with the 9x and 9x. And when it's time to simplify, we can divide both top and bottom with the 3. So 3x minus 4 and 3x minus 4 are your two factors. And you would be at the same point again and the same solution. Okay, so your choice, you can use any method. All right, next we have negative 2x squared minus 4x plus 30 equal to 0. So first of all, I'm going to try to make my life easy by dividing everything on both sides with a negative 2. Why? Because that's my GCF. And if your GCF is a number, you can go ahead and divide both sides of the equation with that number. If you're factoring a trinomial and you have a GCF in there, don't drop that GCF. You want to carry it on with your final factors. But if it's an equation, you can go ahead and divide both sides of the equation with the same number. It's totally okay to do that. So x squared plus 2x minus 15 equal to 0. Two numbers that multiply to give me negative 15. So you can go ahead and draw the x if you need. And think about the numbers that add up to give you positive 2 are 5 and negative 3. So x plus 5, x minus 3 equal to 0. So I'm going to get my two solution, which is positive 3 and negative 5. Here's example number 9. Looks like there's a lot going on in example number 9. Let's try to start with the first step that I know, that I'm going to bring everything to one side to make my life easier. So I'm going to be adding 5x squared to the left side. And then I have negative 20x plus 6x. And I'm also going to be bringing 5 to the left-hand side. So right-hand side becomes 0. I took everything from the right-hand side to the left side, and I did change their sign. So whatever was negative on the left-hand side became positive on the left side. Whatever was negative on the right-hand side became positive on the left side. So 9x squared minus 14x plus 5 is what I'm left with. So 9x squared minus 14x plus 5 looks like I'm going to be trying to factor it now. It looks like it's, no, that's, okay. So 9 times 5 is 45 and negative 14. Think about two numbers. They multiply to give you positive 45 and they add up to give you negative 14. So what are the two numbers? Multiply to give you positive 45, add up to give you negative 14. Would 9 and 5 work here? Would 9 and 5 be okay? Can we use 9 and 5? Because they both multiply to give you 45 and they add up to give you 14. If we make them both negative, they will add up to give me negative 14. That's what I want. So because your first term is something other than 1, we have to divide both sides with it. And now it's time to simplify. So that's going to be simplifying. And the second fraction cannot be simplified. So now x minus 1 and 9x minus 5 are my two factors. When I plug x minus 1 equal to 0, 9x minus 5 equal to 0. So I get x equals 1 is my one answer. 9x equals 5 and x equals 5 over 9. Getting the variable by itself. So there's my two possible answers. If x takes on the value 1, then left hand side and right hand side will be equal. Or if the x takes on the value 5/9, again the left hand side and the right hand side will be equal. Here's example number 10, and I would be adding another one, example number 11 in here as well. Let's just look at example number 10 for now. We have x cubed minus 12x squared plus 32x. Think about it. What should be the first step here? What should I do first in this case? What's the first step in this problem? Looks like the first step should be I would be able to, let's see, x cubed minus 12x squared plus 32x equal to 0. I can pull out an x, that is my GCF. X squared minus 12x plus 32 equal to 0. Think about two numbers. They multiply to give you 32, add up to give you negative 12. 8 and 4 looks like if I make them both negative, that should work. 8 and 4 should work if I make them both negative. Yeah, that sounds right to me. So now my first number is 1 here, so I don't need to worry about dividing with anything. And I can get x minus 8, x minus 4 equal to 0. Now using the zero product property, for zero product property, we can go ahead and say that this will leave us with, let's check, x equal to 0, or x minus 8 equal to 0, or x minus 4 equal to 0. So either the first factor is 0, which is right here, or the second factor is 0, or the third factor is 0, because product of three factors is 0. When I try to isolate the x from here, I would end up adding 8 to both sides. When I try to isolate the x from the last equation, I would end up adding the 4 to both sides. So there's three solutions. Third degree equation, three solutions. Okay, I'm going to add one more problem over here, which is going to be solved. And there's 6x minus 42 plus xy minus 7y equal to 0. Now this equation is a little bit different than the ones we have seen so far. One thing that it's not a quadratic equation. It's not a quadratic equation. And we have the 4 terms. So anytime you have 4 terms, and we talked about earlier in the beginning, if you have 4 terms, 2 terms, you try this. 3 terms, you try this. 4 terms, you try factoring using grouping. So let's go ahead and try factoring using grouping. That means I'm going to group the first two terms together and the last two terms together. The common factor in the first two terms is 6, so that gets pulled out, x minus 7, plus the common factor is y, x minus 7. We can pull out x minus 7 here, and we'd be left with 6 plus y in the second parentheses. So common binomial factor here is x minus 7. All right, so now product of two factors is 0. One of them must be 0. So either x minus 7 is 0 or 6 plus y is 0. To isolate, I get either x is 7 or y is negative 6. That means this equation, the one we started with, the left-hand side will become 0 if x is equal to 7 or y is equal to negative 6. Again, one more time, I suggest that you read this portion again and memorize all this, because we'll be mixing up all the strategies of factoring we've talked about so far when you're solving a quadratic equation by factoring.